today with our quadratics. And you might be thinking, Miss Gal, okay, this opening thing looks just like a question from our quiz last class. And you're right, same kind of format. We're being asked for the same types of things. So let's start with letter A. Is this graph going to open up or down? So what's the basic shape of our graph going to be? It's going to open up because that x squared term is positive. So we are going to open up. For part B, when we go to find those x-intercepts, aka we call them our zeros, to find x-intercepts, 0 goes in for y. And then what we've been using is factoring. We have just a plain x squared there. So most are like, yes, good. That means we can use that shortcut. So we're going to multiply two numbers together to get 8. And when we add those two numbers together, we need to get negative 8. What do you think might work? I know when we think of 8, for most of us, the first thing that pops into our brain would be 4 and 2. Well, 4 plus 2 can't give me 8. So maybe like, oh, Miss Golly, use negative 4 and negative 2. Well,
wait, I have a question.
Yeah.
What's the difference from this and what we just learned?
We're going to see in just a second. So, again, what we're doing right now, it does look the same. But how's our factoring going? Well, let's see, what else do we have? We have 8 and 1. Anything getting us that sum of negative 8 yet? So when we add, we get negative 8? Well, maybe negative 8, negative 1. Do any of those pairs work? No. So far, when we've been graphing our quadratics in standard form, again, remember, quadratic means highest exponent is 2. Standard form means we have our squared term, our term to the first power, and then our constant. So far, when we've been factoring them, we've been able to find those number pairs. This one we can't factor, but it doesn't mean we can't graph it. But in order to find those x-intercepts in some of our other pieces, we need to use what's called the quadratic formula. Now, since this is the first time we're going to be using this formula, I'm not going to make you memorize the formula. I will give it to you on any quizzes or tests. But when you guys see this again, if you see it again in geometry or algebra 2, at that point your teacher will expect you to memorize the formula. Okay, so just so you know, I will not make you memorize the formula. You need to be able to use it though. So here's how this formula works. When we have our standard form, we have our ax, a is the number in front of x squared, bx, b is that coefficient or the number in front of x, and then our c is our constant. Constant is just that plain number without a variable. So what we do is we pick out the different values for a, b, and c, and we substitute into the formula. Now, one piece of that formula, though, that can save us a lot of work is called the discriminant. I'm right down here. Interpreting what's called the discriminant. The discriminant, I just want to show you the connection here. The discriminant is the piece that's underneath that square root. We've solved equations with square roots before, and we found a couple different things can happen. If what's underneath the square root is bigger than 0, or in other words, bigger than 0 means positive. So if the value underneath the square root is positive, we saw this in our last unit when we solved with square roots. If the value underneath that square root is positive, we got 2 solutions. We, in turn, had 2 x-intercepts on our graph. So if the number underneath that square root is positive, it's the same thing we saw last unit. We're going to get 2 solutions, which for our graph means 2 x-intercepts. Now, if in turn, the middle one, the discriminant, which is the piece under the square root, if it equals 0, if it is 0, we saw this last unit, that meant that we just had one solution and we ended up with one x-intercept on our graph. So these connections are not any different than our last unit. This formula is new for us, but how we interpret those square roots will not change. Last but not least, if what's underneath that square root being less than 0 means it would be negative. We worked with square roots, like I said earlier, last unit. If what was underneath that square root ended up being negative, we had no real solutions, and we did not have any x-intercepts on our graph. So when we use the quadratic formula, so our factoring fails us. If factoring doesn't work, it doesn't mean we can't graph or we don't have a graph. It just means those x-intercepts, well, they're not super pretty. They're not going to come out to be integers or some really, really nice decimals for us. So when we use our quadratic formula, we want to focus on the piece underneath the square root first, which is called the discriminant. If the discriminant turns out to be negative, you don't have any solutions and you get to stop there. So by finding the discriminant first, guys, we're not creating any extra work. Finding the discriminant first can actually make less work for you. And it's a piece we have to find anyway as part of our formula. So let's try this out. I just want to do 3 examples with you with this formula and give you some time to practice it. And then tomorrow, we're going to use this formula to help us graph. So when our factoring fails us, here's what we can go to. And this formula, it won't fail us. No matter how many x-intercepts we have, no matter what the x-intercepts turn out to be, this formula will work for us every time. So the first thing you always want to start with, I like writing this down. I pick out my A, I pick out my B, and I pick out my C. I actually write them down. I don't just keep staring back at the equation to try to pick them out. The A, we've been looking at the A quite a bit. The A will tell us if we open up or down. The A is always in front of our squared term, so our A is positive 3. The B always goes with our X. It is 2. And then our C stands for constant. Constant doesn't change. If a number doesn't have a variable with it, it's never going to change. If the -5 doesn't have an X with it, it's going to stay a -5. The thing I want to caution you the most with this formula, especially since I'm not going to make you memorize it for this round, you have to watch your signs. If there's a subtraction sign like we have here in front of the 5, that means that value is negative. So you have to watch your signs. That's where I would say most mistakes come from with our formula. All right, so now what we want to do first, I want to do the piece underneath the square root first. I'm just going to label that discriminant. It doesn't really have a specific symbol for it. And the discriminant piece, guys, it's right up above. I've put a little box around it. It's the piece underneath the square root. So we're going to take our B value, which is 2, and we're going to square it. We're going to subtract 4 times our A times our C. Notice I'm using parentheses every time I substitute in. I would not try to use multiplication symbols when you're using your calculator or things. Please, 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 just enter that in your calculator exactly as you see it. Whether you have a graphing one or whether you're using one of mine from the cart, they both have the feature to have everything stay on your screen. You need to make sure you're using all the parentheses as well. I'm going to go ahead and bring up my graphing calculator. Hopefully this didn't freeze on me today too, which it might have. It looks like it did on me. So go ahead and enter in, again, exactly as you see it in your calculator. And let me know what you come up with. My calculator's frozen up here. Help me out. 64? Okay. So 64 is our discriminant. So if I look at my cases up above, remember this is the piece that's going to go underneath the square root. I have a positive, so that means we should come up with 2 real solutions, and if we graph 2 x-intercepts. So I'm just going to make a little note here that we will have 2 real solutions, which means 2 x-intercepts on our graph. So now you might be thinking, okay, Miss Guy, that's extra work because now I have to find those solutions. It's not extra work though, guys, because that's part of our formula. That's just the piece that's underneath that square root. So now what we need to do, since we know, hey, we've got 2 solutions, aka 2 x-intercepts, now we have to use the full formula and find them. So we're going to go x equals, and the first piece you see in the formula, it looks like a negative b. You can also read that as the opposite of b, or the opposite sign of b. So we have x equals, here's the negative sign that's part of the formula itself, and then the b we substitute in is a 2. So that first negative sign there, that's there, guys, no matter what sign your b has. It is a negative b, but it's also read as the opposite of b. So what is the opposite sign of your b? Then we have the little plus minus symbol. We saw that last unit when we were solving using square roots. I introduced you to it, said, hey, you can try it out if you want. We're going to see it later. Well, here's our later right now. So we have that little plus minus. We will revisit what it means as we go to solve. And then now you have the square root. Guys, save yourself the work. Don't redo all that under there. We already did that. Oh, let me draw that up here a little more. We already did that part. So see how finding the discriminant, it's not more work. It's part of your formula. It's part of your formula. But by singling that out first, we know how many solutions we should end up with, and if we're graphing, we realize how many x-intercepts we should have. It's not extra work to find it first. It goes right in your formula. And then it's just all divided by 2 times a. Now, for most of us, this is just going to be kind of that piece where we really need to take it step by step and to try to not shove everything in our calculator or do too many steps all at once. I'm going to go ahead and just simplify. I'm going to take this as many steps as I can here. I'm going to just simplify first the 2 times 3 that's in the denominator. I'm just going to simplify that first before I even start trying to deal with the square root. All right, so what we have now is now we have to worry about our square root and that plus minus. I'm going to try the square root first and see what that works out to be. I'm just going to go down here to the bottom. The square root of 64, we're in luck. That works out to be perfect. It is 8. So I'm going to do a little plus minus. I'm going to put my 8. And we have divided by 6. So just make sure, simplify little pieces as you go. Once you get more familiar with the formula and you want to start taking on a couple steps in one, that's going to be up to you. So now we have to deal with that plus minus. So here's what I like to do. I like to go ahead and just split into my 2 different cases. Remember, we're going to have 2 solutions. Now I'm going to break it down. I'm going to split apart the plus minus. So I'm going to have negative 2 plus 8 divided by 6. And I'm going to have negative 2 minus 8 divided by 6. Notice the only thing that changed signs was the 8 because it had the plus minus in front of it. The plus minus means one of my cases has a positive 8. The other case or other solution is going to have the negative 8. Now from here, here's where we have to be careful with what we put in our calculator. We saw this when finding our axis of symmetry earlier this unit. We have to make sure we do the addition first. If you want to put this all in your calculator at one time, you have to put parentheses around the numerator so your calculator does the addition or subtraction first and the division last. If you just put it in the calculator as is, without parentheses, your calculator is going to divide by 6 and then do the addition. We don't want that. So here's what we have. We end up with 6 divided by 6, which is 1. And we end up with negative 10 divided by 6, which is negative 1 2/3. I realize we're not going to go full out and graph this yet. So let's get in the habit. And let's go ahead and write those as our x-intercepts. We are going to put this on the graph tomorrow. I want us to focus on the formula today. So this quadratic formula, guys, we can use it no matter what our x-intercepts are going to turn out to be. Whether we have 2, 0, 1, whatever we have. So I just want to do a couple more examples with you, and then I want to turn you loose to do some yourself. So then tomorrow when we go to graph, we're ready to rock with this, hopefully. So let's start at the very beginning, picking out A, B, and C. Be very careful when you're picking out A, B, and C. Since we're first being introduced to this, I'm making sure that I'm keeping those equations in that standard form order for you. When you guys get up to the next level of this, things might be out of order and you might have to rearrange, but we're first getting introduced. So just make sure you're really focusing on that, hey, A is in front of the x squared. B is with the x, C is the constant by itself. Let's start by finding the discriminant first. Let's find the discriminant first. So we have our b squared minus our 4 times our a times our c. Please make sure you're using the parentheses, especially around that squared value. If we don't put parentheses around the -5, we've seen this a few times this trimester. If we don't put the parentheses, the calculator is going to say -5 squared is -25, and that's going to throw us way off. So go ahead and put that in. Let's see what we get. We have -5. We're going to square it. -4 times 2 times -4. All right, are we getting 57?
Yep.
We matching 57? Yeah. All right. Now, I know for some of you, you're very good with your perfect squares, and already you're like, oh my God, this one isn't going to work out pretty. You're right, it's not. But let's take it piece by piece, and let's see what happens. So because 57 is positive, we're going to have two real solutions, which when we go to graph tomorrow, means we're going to have two x-intercepts. Again, finding that discriminant first, guys, it's nothing extra. It's going to go right into our formula. So speaking of right into our formula, let's go ahead. X equals, it has a -b first. We can also read that as the opposite of b. So what happens is, guys, here's the negative that's part of the formula, and then here's my b that's -5. So the negative that's part of the formula, we can't take that away just because, well, the b is already negative. The opposite of b. So what's going to happen with the -5? What's it going to become? Positive. Yeah, just 5. So my b was -5. So the opposite of that would be +5. I like to read that -b as the opposite of b. Substitute it in, though, if you need to show yourself that it will become positive. Plus or minus the square root. And remember, the discriminant that you found, please don't do the work again. My people that go through and do the b squared minus 4ac again, they see the discriminant as a whole lot more work. It's not. It's part of the formula. All right, then we have divided by, and we have 2 times our a is what we're looking at for that piece. All right, so just like we did the last time, I'm just going to go ahead and simplify a little bit. positive 5 plus or minus the square root of 57, and then 2 times 2 is 4. I'm going to simplify as much as I can before I start messing around with the square root and the plus minus. So I'm going to make sure I make my b my opposite, and I make sure I take care of the 2a in the denominator before I start trying to mess around with plus minus and things like that. Now, if we try to take the square root of 57, we know it's not going to be pretty because 57 is not a perfect square. And we get 7.5498 and a whole bunch of stuff after that. So if you're looking for an exact answer, which when you see this later on in Algebra 2, they might ask you for an exact answer. That means we leave the square root there. But for our purposes, if I want to be able to graph these intercepts, we're going to do a little rounding. We have to. So I'm going to say for us to always round to the nearest hundredth. So that's 2 decimal places after our decimal point. So I'm going to say this is going to be x. Now, since I'm going to round, we're going to go squiggly equals. We're going to do our approximate. And we're going to have 5 plus or minus, and the square root of 57 would round roughly to 7.55. So we're going to go with our squiggly equals. We want to be able to graph these, so we're just going to round to the nearest hundredth. Again, when you guys see this in Algebra 2, you guys are going to start working with keeping that square root there. But that's something you'll work with when you get there. Algebra 1, we introduce you to the formula, get used to using the formula, show you how it can be used to help you graph as well. All right, so let's go ahead and split. So 5 plus our 7.55 divided by 4, and then our 5 minus. Remember, guys, just the value that the plus minus is in front of changes. Everything else stays the same. 5 is still positive, 4 is still positive. You have to do the addition first. So 5 plus 7.55 divided by 4. And again, if you want to go ahead and round to the nearest hundredth, I am fine with that. That's okay. Just make sure you're using squiggly equal signs every time you round. Again, for our purposes in Algebra 1, I want to introduce you to the formula, get you familiar with the formula, picking out A, B, and C, what the discriminant is, what the discriminant tells us, and then how to use the formula. When you get to Algebra 2, you're going to learn how to keep those answers more exact than what we are. But for our purposes now, we're okay rounding to those nearest hundredths. So these would be, and I know they're not going to be the greatest things in the world to graph, but these would be the intercepts on our graph. They don't always work out perfect like we did when we used our factoring. They won't always be perfect, and that's okay. That's okay. Let's just do one more together. So far we've seen one that we had 2 solutions. We ended up with a nice perfect square of 64. Everything worked out really nice for us in example 1. And that can happen with the quadratic formula. Example 2, we had 2 solutions, but we ended up with the square root of 57. We had to do some rounding. And that's okay. That happens when we're using the quadratic formula. Last but not least, let's take a look at number 3. Be very careful when you're picking out your A, B, and C if it looks like there's not a number in front of one of the terms. So if I look at this, I know some of you are thinking, Miss Golly, so we don't have an A? Yeah, it is a 1. We do have an A. It's a 1. It's not a 0. And guys, for A, B, and C, you can never put a variable there. So your A is not x squared. I cannot put x squared in. I can't put x squared into my formula. That's not going to work. Then my B, watch your sign, is -4. My C is +4. Always find the discriminant first. Again, the discriminant will tell you how many solutions you should end up with, which is how many intercepts would be on your graph. But the discriminant piece, guys, it's the part that goes underneath the square root. And by doing that first, it makes this formula way more manageable. Way more manageable if you find that piece first. All right, so here we go. We're going to have b squared. Oh, and I literally just wrote b. Negative 4, here we go, squared. Minus 4 times a times c. Now, please don't skip over, writing the 1 in there for your a. Don't skip over that part. All right, so what are we coming up with for our discriminant? We're getting a 0. Now, I know sometimes you're like, oh, 0, that means we can't do anything. If you need to, guys, you can reference what I have right on your sheet for you. If our discriminant's 0, that doesn't mean we have to stop. It just means we're just going to get one solution. We're just going to have one x-intercept. So we have x equals the opposite of b. If you want to jump in and just put a positive 4 there, you can. If you need to show yourself, here's the negative that's part of the formula, and then here's my b value. It's going to be how comfortable you get with this formula and how fast you get comfortable. Plus or minus the square root, I put my discriminant in there. It's going to be a 0. And then 2 times my a is 1. Before I mess around with the plus, minus, or the square root, I take care of any other simplifying I can do. I have a negative 4. I'm going to make that a positive 4. And then 2 times 1, I'm going to make that a 2. I'm going to do any little simplifying I can first before I mess around with finding my square root and doing the plus minus thing. Oop, and I got ahead of myself here, guys. Sorry. Discriminant of 0 means we're just going to have one solution, which means one x-intercept on your graph. It's really nice finding that discriminant first, then you know exactly what to expect. I should only get one answer. If I graph, I only have one x-intercept. All right, so we have 4 plus or minus the square root of 0 is just 0 divided by 2. Now, I'm not going to split this into 2 cases because if I add or subtract 0, I'm just going to get 4. So I just have one solution. I just have one. So when you're working with this formula today, you might get 2 solutions that work out really nicely, like example 1. You might get a solution or 2 where you have to do some rounding. You might just get one solution. Now, the only case I did not put on here, but we cannot forget about it. And I didn't take the time to show it because really it takes care of itself. If your discriminant comes out to be negative, and you could show yourself by putting the value in your calculator, you have no solution, you have no x-intercepts, you move on in life. Okay, I didn't take the time to put one of those up there. We have a couple different ways with 2 solutions. We have a 1 solution. If your discriminant comes out to be negative, you have no real solutions, move on. Don't work your way through the rest of the formula. Negative discriminant, like we have here in our 3rd case, move on. Okay? All right, I want to give you guys some time to practice this.